Question 17 tests a whole mixture of things. It's about oscilloscopes, it's about batteries and EMF and internal resistance, and it's also about alternating currents. So for the first part of the question, there's the circuit. You've got a battery, you've got two switches, so you can connect it to an oscilloscope and you can also connect it to a resistor. And here's the trace on the oscilloscope, and it says that if both switches are open, in other words, the oscilloscope's not connected to the battery and the resistor's not connected to the battery, it says the spot on the oscilloscope is at point A. So in other words, this oscilloscope's set so there's zeros in the middle of the screen. It then says when you close switch 1, so that the oscilloscope is connected across the battery, but S2 is open, so the resistor isn't connected. So when you connect the oscilloscope across the battery, the dot moves from A up to B, and it says state what that deflection represents. So B is the deflection when the oscilloscope's connected across the battery and there's no resistor connected to the battery. So there's no current flowing through the battery. Well, there's a special name given to the voltage across a battery when there's no current flowing. What is that special name? And also, what's the value of that voltage, given that the oscilloscope is set so it's 2 volts per division going up on the Y direction. Next part says that you keep switch S1 closed, so you keep the oscilloscope connected, but you now close switch S2, so you now connect the 15 ohm resistor to the battery, so the battery can now drive current through the resistor. And it says the spot moves down to C. In other words, we've lost some of the voltage, we've got some lost volts. But you've got to explain why, when there's a resistor connected, so there's a current flowing, why will the voltage across the battery be less? So why do we lose some of the voltage? Then I ask you to calculate the current through the resistor when the resistor is connected. So how do you find the current? Well, you know it's a 15 ohm resistor, and you also are able to find out what's the voltage across the resistor when it's connected. You'll find that from the oscilloscope. What's the voltage when the resistor is connected? So when you know the voltage, you know the resistance, so you can find the current. Then I ask you to find the internal resistance of the battery. Hopefully you've already referred to internal resistance earlier when you were answering some of these questions about why you lost some of the voltage. So the way I would approach it would be by thinking about the lost volts, because we know that the current in the circuit and the internal resistance and the lost volts are closely related. So I'd use that idea to find the internal resistance. Part B says that the oscilloscope is now connected to an alternating voltage of RMS value 5.3 volts. And the first thing you've got to do is calculate the peak value. Now if you can't remember how to do that, it is on the data sheet, the connection between RMS and peak value. It's still got to do a little bit of work though, because the formula on the data sheet tells you how to find the RMS value when you know the peak value. And in this question, the RMS is the thing that we know, the peak value is the thing we're looking for. It's got to do a little bit of rearranging. Draw on a copy of the grid below. Well, if this was a real exam, of course, it wouldn't be in a textbook and you'd have the grid there printed for you to draw on. But it isn't a real exam, and I don't want you drawing the book, so you do have to do a copy of it. What would you see, given this peak value that you've just calculated? The time base remains switched off, so you're not going to get a trace. The dot's never going to move from the centre line of the screen, but you've got to work out how far up and how far down it goes, and it tells you it's 5 volts per division. That's made that quite easy for you, because if I was setting the question, I'd be awkward. I would tell you what the frequency was and what the time base was and expect you to draw a curve, but you don't have to do that in this question.